Below are three graphs, A, B, and C, labeled in no particular order. One graph is the graph of the position of a car. The next graph is the graph of the velocity of the car, and the third graph is the graph of the acceleration of the car. So our job is to identify which is which. Now recall the connection between these three things is the derivative of position equals velocity, and the derivative of velocity, hence the second derivative of position, equals acceleration. So let's start by looking at curve A. And if we were looking to see if this could be the position of the car, then the velocity would be the derivative, which would be positive, then it would be 0, then it would be negative, then it would be 0, then it would be positive. And the other two graphs do not ever go below the x-axis, and so they're never negative, and so this couldn't be the position function because its velocity graph would not exist here. So let's look at graph B and see if this was the position. The velocity would be positive, the velocity would be 0 right here, then the velocity would be negative. Okay, so let's see, velocity would be positive, velocity would be 0 right here, and then velocity would be negative. It looks like A is the derivative of B, but then we knew that the derivative of A did not exist here, and so B could not be position, because if its derivative was A and that was velocity, we'd need the derivative of that for acceleration. So C must be the position graph, and let's look again to make sure. Positive, looks like it's larger value here, and then going back to approximately 0 for the derivative, but also always staying positive, never going negative. So if this was the position of the car, you can see that B is its derivative. Positive values for B. The largest value would be right in here, and then start to get smaller and approach 0 for the slope of the tangent to the curve, and that's exactly what B does. And then if we looked to see that A is the derivative of B, we've got positive, we've got 0 right here, and then we have negative here. And so we've got this figured out. This one, C is position, and B is velocity, because we can see the derivative of C is B, and A is acceleration, because we can see that the derivative of the B is A, and therefore the second derivative of position is acceleration there, and we'll be looking a little more about how those graphs would be connected or what that would tell us in a later section.